Hello everyone, good afternoon. Dear authors and invited guests, welcome to the technical session 6A. Myself Siddhi Auti and this session would be moderated by me. I, on the behalf of Global Knowledge Research Foundation and GR Scholastics LLB, it is my great pleasure to welcome you all to the 10th International Conference on ICT for Sustainable Development, ICT4SD 2025. The 10th edition of the conference is being organized in a hybrid mode. The physical event is being held today in Goa, and the virtual event is being held via Zoom meeting from 17th to 19th July. I hope you all will enjoy this knowledgeable and interactive session throughout the day. In this session, we have 10 presentations. Each presenter will be given a time span of 10 minutes for the presentations and 2 minutes are for question answers. So I will be raising a reminder after 7 minutes of your presentation. So this is a kind request to all the participants to please respect the time constraint. Also, there is another request to all the participants that you stay connected with us till the closing remarks. If you have any query or update, you can just write it to me in the chat box. Now, before we proceed with this session, I would like to introduce you all to today's session chair, Dr. Paras Kothari. Dr. Paras Kothari is a professor and head Uh, Dr. Kothari is a professor and head at Gitanjali Institute of Technical Studies, Udaipur, India. He is experienced head of training with a demonstrated history of working in the professional training and coaching industry. Skilled in PHP, databases, mobile applications, window communication foundations, and Android development. A strong operations professional with a doctor of philosophy, PhD focused in marketing management applications from Mohanlal Sukhadia University. Welcome, sir, for today's session. Would you like to say something?
Hey, good morning, everyone. Thank you, Siddhi, for the nice introduction. And I hope we will enjoy this knowledgeable session along with our research papers and our queries. And I wish all the best to all the participants and very curious to listen of the paper. Thank you. Over to you, Siddhi.
Okay. Thank you, sir. Now we will, without wasting any time, we will go on to the first presenter of today's session. So the very first presentation is by Mayuri Gawande from Amrut Vahini College of Engineering. And the paper title is Air Quality Monitoring System Implementation using ARIMA and LSTM. Mayuri ma'am, please start with your presentation.
Yes, let me just share the presentation.
Yes, sure.
Okay, is my screen visible?
Yes, ma'am, it is visible.
Okay. Okay, so I'm really honored to present my research work, air quality monitoring system using ARIMA and LSTM. So the main author of our research work is Dr. Ganesh Puri, and I am Mayuri Gawande, representing our research work in the research work. So in our project, we observed that air pollution is a major problem in urban and rural areas. There is a rising concentration of NO2 pollutants like NO2, CO, and ozone, which is contributing to severe health and environmental issues globally. And moreover, the network of systems monitoring the air pollution is very sparse, and there is a growing need for continuous and real-time air quality monitoring. So the limitation of traditional existing system is that the network of ground stations of the traditional monitoring system is very sparse, and the setup of those monitoring systems is extremely expensive, due to which there is a limited geographic coverage. Moreover, these systems are static and do not have predictive capabilities and are not capable of giving real-time alerts. So in our project, we have tried to develop a low-cost real-time air quality monitoring system. For our project, we have tried to monitor three pollutants: nitrogen dioxide, carbon monoxide, and ozone. And we have used ESP32 model and IoT sensors for local real-time monitoring. And then we have used the data collected from the nearby ground stations of our region and the local data collected, and we have used the data set and used for training the model to make future predictions. We have used ARIMA model to make predictions of next 5 hours, and we have used LSTM model to make predictions of next 12 hours. And then we have displayed the results on a web-based dashboard on which we can view live data, historical trends, and alerts. So the objective of our project was to develop a low-cost, real-time predictive air quality monitoring system, because the network of existing systems is very sparse, which does not allow us to monitor the changes occurring in local regions. So we have integrated we used two machine learning models, ARIMA, which is a statistical model, and LSTM, which is a deep learning model for long-term and short-term pollution forecasting respectively. For local monitoring, we have used IoT sensors and ESP32 microcontroller, and visualize the data through dashboards and using the color cards. Then we have validated our sensor data using the government approved CPCB stations testing data. So this is the architecture of our project. The architecture consists of 4 layers: sensor layer, pre-processing layer, data analytics layer, and user interface layer. In the sensor layer, we have used 3 air quality sensors: MQ135, MQ.
I think she has lost the connection.
Yes, I think there might be some issue. We'll just wait for a minute. Hello. Mayuri ma'am, please respond if there is some issue. Okay, in the meanwhile, we can have some other presentation and then we'll solve our query and we can continue later on. So I think we will proceed to the next presenter. Now I can see I don't recognize most of the participants who have joined. So I'll just announce the names of the participants right now, and just give me a response if you're there in the meeting and start with your presentation. So the next one is Mandapati Bindu Shri from Amrita Vishwa Vidyapeetham. Ma'am, if you're there in the meeting or any of the co-authors are there, please give me a response and start with your presentation.
Hello, am I audible?
Yes, ma'am.
Yes, ma'am.
Siddhi, what happened with the first candidate?
Sir, I will just text her. There might be some internet issue, so we can get her back and she can continue from her intermediate presentation.
Okay. Okay, go ahead, please.
Yes.
Can I start?
Yes, ma'am. Sure.
Good morning, everyone. We are excited to present our project titled Cloud-Based Crop Health Monitoring System. This project was developed by our team, Chakravaram Haripriya, Navneet Rajmohan, Kirtisai Nagasudha, and Bindushree. The objective of our project is to leverage machine learning for smarter agriculture. We have designed two key systems: crop health monitoring system and crop recommendation system. Crop health monitoring system to predict if crops are healthy or not based on environmental factors, and crop recommendation system that advises which crops are best suited for the region's current conditions, and etc. These models are deployed on AWS SageMaker and connected through a Flask web application, providing real-time actionable insights for farmers. This approach enhances decision making, reduces waste, and promotes sustainable farming.
Agriculture faces major challenges today, from climate change to soil degradation. Traditional methods for monitoring crops are often manual and imprecise. To solve, we developed a machine learning based solution that analyzes environmental data. Using AWS SageMaker, we train models for crop health prediction and crop recommendation. Our system is integrated into a Flask app where farmers can input data and receive instant suggestions, making agriculture more data driven and sustainable. Our methodology started with data collection and pre-processing. We gathered environmental data like temperature, humidity, soil moisture, and sunlight from sensors and existing records. We cleaned the data by removing missing or duplicate values, normalized features, and encoded categorical values. This data was stored in AWS S3 bucket and making it easily accessible during model training in SageMaker. For crop recommendation system, we train multiple models such as logistic regression, XGBoost, random forest, and SVM. We evaluated them using metrics like accuracy, precision, recall, and F1 score. After evaluating, we deployed the best performing model with farmers can access through a web interface. For crop health monitoring system, we created a binary classification model. We used random forest and XGBoost, both known for high performance with structured data. After testing, we deployed the top model on SageMaker, enabling real-time crop health prediction in the Flask app. We then built a Flask web application allowing user to input environmental conditions and get real-time crop health and recommendation results. Flask was chosen for its lightweight nature and easy integration with SageMaker endpoints, making the interaction seamless and fast. To ensure scalability, we used AWS API Gateway for reliable cloud deployment. We also validated the system using cross-validation to avoid overfitting. We prioritized robust evaluation using accuracy, precision, recall, and F1 score. This is how it looks in the web app. Our models delivered impressive results. For crop recommendation system, uh, we got 99% accuracy, precision, recall, and F1 score. And we selected random forest for deployment. For crop health monitoring system, XGBoost reached 96% accuracy, 100% recall, and F1 score also 98%. The Flask application connected both models, delivering real-time responses within 5 seconds and maintaining over 92% accuracy in real-world tests. In conclusion, our project demonstrates how cloud computing and machine learning can revolutionize agriculture. We successfully developed two systems, crop recommendation and crop health monitoring system, helping farmers choose the best crops. In the future, we aim to integrate climate forecasting, optimizing the models further, and even use IoT-based real-time monitoring for better precision. Thank you.
Thank you, ma'am, for your presentation. Sir, are there any questions?
Yes, I want to know something. It's my query related with the research. That's Bindushri, can you tell me what
Yes,
are
sir.
the possible applications available or can be developed based on your this research paper?
Sir, I didn't get you.
What the application can be developed or what the on the based on your research paper, especially while you are talking about the crop recommendations. So how you can recommend the crop to the farmers and that time and that crop. How we can develop that
Sir,
system?
yes, sir. For different climates and for in different villages or different places, we have different climates and temperatures, no, sir. For them, based on the inputs, what is the temperature for them at present, they'll give as input, and it will recommend which crop can be better in this situation.
Yes, that is the concept which you are using in the recommendation process, right?
Yes, sir.
But what you can develop based on that? Based on this model, can you develop some of the web applications, or can you develop some of the apps through which we can aware the farmers to get the what this thing, which crop can be with this climate and this situation?
We can develop a web applications.
So in your future research, do you have any plan in which you want to incorporate your this research with the web applications or mobile applications?
Yes, sir.
All the best. Okay, good. Good luck.
Thank you, sir.
Thank you, sir. Now we will go on to the next presenter. So the next participant is Mohammad Azruddin from Keli Technological University, India. And the paper title is Evaluating 5G Network Performance, a simulation study of beamforming, massive MIMO, and small cells. I request Mohammad sir or any of the co-authors to please start with your presentation.
Hello.
Hello?
So is my screen available?
No, sir. Actually, you'll have to share your screen again.
I'm a co-author of Muhammad Azruddin.
Yes.
Actually, I'm not able to connect. So can we move forward and come back?
Is my screen
Sure,
available?
sir. Yes, your screen is visible.
Yeah. Okay. Thank you.
Okay, we can see your screen, so you're continuing with the presentation, right?
Yes.
Okay, sir, I believe there are like five different paper titles for the same authors and co-authors. So you all will be presenting all five papers all together.
No, there are different teams. They are our
Achha.
just guide. We are co-authors.
Okay, sure, sir. So you are just presenting for this paper title, right?
Yes.
Okay, please carry forward.
So, good afternoon, everyone. So here we are about evaluating 5G network performance, simulation study beamforming massive MIMO and small cells. So our project simulates a 5G network. To understand how different configurations, namely small cells, massive MIMO, and beamforming affect performance metrics such as latency, throughput, and packet loss, we have used MATLAB and its 5G toolbox to build a configuration environment where three types of traffics like voice, video, and IoT were tested. Each traffic type has a unique network demands. So we randomize parameters like key modulation schemes and coding rates to evaluate performance under realistic conditions. So this allowed us to identify which configurations is more suitable for a particular traffic profile. So 5G is not just a speed upgrade. It's designed to support a wide variety of applications from high-speed video streaming and virtual reality to low power, low latency IoT devices. 5G is built to handle everything from high-speed video calls to billions of IoT devices all at once. Technologies like small cell, massive MIMO, and beamforming plays major role in improving network performance. This project focuses on how each of these configuration affects key metrics. So this is our methodology. We have used a simulation environment as a MATLAB. We have used a 5G toolbox and communication toolbox to create a customizable simulation setup. This toolbox provides a accurate modeling for physical layer basis on real 5G standards. Now let's walk through our key parameters. So we have used a carrier frequency as 3.5 gigahertz. This is a part of a mid-band spectrum in a 5G. It offers a good compromise between range and speed. Like it is like 4G is for example, 4G uses a carrier frequency around 2 gigahertz. We have used 3.5 gigahertz, and we have used bandwidth as 100 megahertz. So think of it this as a wide width of a highway for a data. Wider bandwidth means more data can flow simultaneously. 100 megahertz is a typical value used for high capacity 5G deployment. There are three traffic types: voice, video, and IoT, each with unique characteristics and demands. We have used modulation and coding for our accurate 5G reflection. So modulation scheme, we use QPSK, Q16 QAM, 64 QAM. QPSK is the most reliable and poor signal condition because it encodes only 2 bits per symbol. 16 QAM carries a 4 bits of offer higher speed much but need clear signal. 64 QAM encodes 6 bits per symbol, giving maximum speed, but it is more sensible for noise. You can use these three different modulation scheme accordingly. For example, IoT, video, and voice. You can use for voice QPSK because it encodes only 2 bits of data per second. So you don't need high speed for voice calls. Then we have used coding rates as 0.5, 0.7, and 0.9. So this determines how much redundancy is added to for error correction. A rate of 0.5 means that half of bits are for error checking. For example, if a coding rate is 0.5, so 50% of data is used for error correction. Likewise, 0.7 and 0.9 is used for balance error correction through. So network configurations are small cell. Small cell are a low power cellular nodes that cover a small area, improving network capacity. They help reduce congestion in busy areas. For example, in dense areas like malls, stadiums, and urban hotspots, they help offload traffic from large tower and improve data speed in crowded places. So then another one is a massive MIMO. Massive MIMO means multiple inputs, multiple outputs. It uses multiple antennas at both the sender and receiver to improve signal quality. It increases network capacity by allowing more data to be transmitted simultaneously. So it uses tens or even thousands of like hundreds of antennas at both transmitter and receiver. By doing so, it allows the base station to serve multiple users at the same time, improving efficiency and reducing wait times. Then another one is a beamforming. Beamforming is also another technique we have used here. It is a technique where signals are directed towards a specific direction. Beamforming focuses the signal in the direction of the user. This increases range, improves reliability, and minimizes inferences. It's like using flashlight instead of a bulb. So there are three traffic types. One is voice, video, and IoT. Voice traffic includes phone calls or voice messages. It requires low latency, quick transmission time, but not as much data. Then another one is video. Video traffic involves streaming or video calls, and also like video streaming or virtual reality. For virtual reality, also video included. Then another one is IoT. These devices send tiny amounts of data like sensor reading, but must be connected continuously. They need reliable but low bandwidth connections. This traffic is common in smart homes, healthcare, agriculture, and industry. It has low data requirement but needs a reliable, always on connections. So this is the result. So yeah, as you can see, with massive MIMO, for a second. So this is beamforming. Under beamforming, the network dynamically focuses on signal towards each device. So naturally, we expect good latency performance. Latency was lowest. So you can check here. Latency was lowest for IoT and highest for video and voice. First, and throughput is lowest for video and highest for voice and IoT. And packet loss is maximum to its according to voice and video. According to it varies according to traffic. So this is massive MIMO. With massive MIMO, we saw strong increase in throughput thanks to multiple users and transmission. So you can see latency for voice is lowest and video and IoT is highest. So so massive MIMO uses multiple antennas, so voice and IoT is highest for latency, and average throughput for massive MIMO is highest for voice, video, and IoT. So voice has the highest throughput, and then video and IoT. Then this is small
Hello.
cells. Yes.
Sir, sorry for the interruption, but we are past the presentation time. Can you please get to the conclusion?
So this is one. So we can observe here, voice traffic consistently has the highest throughput. This shows that even basic error corrected modulations like we have used QPSK combined with strong signal to noise ratio performs very well for low data. IoT benefited the most from beamforming due to its speed for stability and low delay. So this simulation helps us to understand how different configurations behave under this realistic traffic. The key takeaway is to know one setup is best for everything. We can have beamforming is great for precision and low latency. And IoT. Massive MIMO works best when speed and users capacity are critical. Small cell are perfect for boosting coverage in crowded locations. Simulations like this let us and fine-tune steps before real-world deployment, saving cost and improvement. Thank you.
Thank you, sir, for your presentation. Are there any questions? If not, then we can
Okay.
proceed.
Yes, we can proceed. All the best.
Okay,
Thank you.
sir, Mayuri ma'am had previously left her presentation in between, and she's back in the meeting now. So we can have her presentation. Ma'am, please give me a response.
Yes, I am extremely sorry for the technical issue earlier. Shall I resume?
Yes, ma'am, please resume from where you had left.
Yes. Okay, so is my screen visible?
Yes. Ma'am, please start from where
Okay,
you
so
left last time.
yes, I left at the system architecture. So I'm resuming from there. So in our research, there are four layers: sensor layer, pre-processing layer, data analytics layer, and user interface layer. In sensor layer, we have used air quality sensors, which collect pollutant data. We have used three air quality sensors: MQ7, MQ131, MQ135, which we have connected to ESP32 microcontroller, and we have fetched the data on the ThingSpeak cloud. Then we have also downloaded the data sets of past 1 year air pollutant data of three ground stations, Ambar, Tarapur, and Pandav Nagari, which are closer to the region we were monitoring. So then we pre-processed both the data sets, and then we passed the data set to the ARIMA and LSTM models. We trained the models to give us the highest possible accuracy, and then we displayed the predictive results and the live data recording on the web dashboard. So in the hardware setup, we used ESP32 microcontroller, which has Wi-Fi and Bluetooth connectivity options. So we use the Wi-Fi connectivity option to capture the concentrations of pollutant. So the MQ135 sensor is used to detect general air quality. So we detected carbon dioxide using this. For MQ130 measures ozone, MQ7 measures carbon monoxide. Connections we use. Then we used ARIMA model. It is a statistical model used for time series prediction. It consists of three components: autoregressive, integrated, and moving average. Autoregressive component has a p variable which uses past values for prediction, and the integrated has uses a variable d which makes data stationary through differencing. Moving average uses a variable q which models errors present in the past predictions. The strength of this model is that it is useful for linear and trend-based data, and it is easy to implement. The limitations of this model is that it can only make short-term predictions and is less effective with long-term dependencies. Moreover, the model struggles in working with non-linear patterns. A stronger model, LSTM, is used to make long-term predictions. It can capture complex long-term dependencies in sequential data and can be used for time series prediction. Its architecture utilizes multiple gates such as forget gate, input gate, output gate, and candidate gate. So this model works by using memory cells which remember the important past trends and patterns. It is excellent non-linear and noisy time series data and can handle long, but it is computationally expensive and more data. Uh, but this model outperforms ARIMA in terms of duration and accuracy and predictive analysis and pattern learning. So, as already said, we have used gas sensors, ESP32 microcontroller. Then we have used ThinkSpeak Cloud for real-time data logging. We have used Google Colab for model training and prediction with GPU support. And we have used Python libraries like Python, Pandas, NumPy, Scikit-learn, TensorFlow, and Keras. We have used Streamlit for interactive user interface and data visualization. For evaluation, we have used RMSE and MSE metrics to assess the performance of the model. And for ARIMA, we have used ACF and PACF and graphs and residual analysis. Then in front end, we are doing real-time sensor data visualization and forecasting the plots of ARIMA and LSTM predictions for 5 hours and 12 hours respectively. Then we are also categorizing the air quality as good, satisfactory, moderate, poor, very poor. And we have represented the color parts which helps general users to understand the changes easily. Then we are also issuing health advisories based on these AQI categories and suggesting actions such as use of masks, then air purifiers, avoiding external activities, etc.
Ma'am, ma'am, sorry for the interruption, but we are past the
Yes, ma'am.
presentation time now. Can we please get to the conclusion?
Yes. Yes, ma'am. So these are the graphs obtained from the models for ozone, carbon monoxide, and nitrogen dioxide. Below are the observations and inferences. And these are the screenshots of our dashboard. So in conclusion, we have monitored real-time air quality of local regions and the AI-based pollution predictions are made using the ARIMA and LSTM model. This hybrid approach helps us to improve the forecasting. Moreover, the use of sensors has improved the data reliability. Then use of health warnings increases the safety and awareness among the citizens. Moreover, this is a low-cost, scalable solution for which helps for widespread pollution monitoring, and we have developed an interactive data visualization with web dashboard. Thank you. I'm open for any questions.
Okay, Ms. Mayuri, as you stated that
Yes, sir.
ARIMA is having some limitations during the non-linear patterns, right? So what do you suggest for
Yes.
the non-linear pattern of the air quality monitoring system?
Sir, ARIMA is a statistical model and it cannot learn previous trends and patterns well. So we can use advanced forecasting models such as LSTM to overcome the shortcomings of this model.
And have you studied some of the non-linear patterns along with the Alexia as well as ARIMA both to find the comparative difference between ARIMA as well as this another one, Alexia?
Yes, yes, sir. There are various patterns such as trend, then residue, noise, etc. So LSTM has memory cells, so it helps us to learn the past data patterns, which improves the accuracy of the model.
And have you published those comparative studies somewhere? Because I don't think that you have read that study in this paper.
Yes, sir, the project is, sir, the research is still under development. So
Okay.
we are yet to publish the comparative study.
Okay, Mike. Thank you. All the best. Good luck.
Thank you, sir.
So the next participant or the paper title is Optimization of Routes of SDN using GNN and DRL. And this paper title will be presented by Mohammad Azruddin or any of the co-authors which are present for this particular paper. So I request the co-authors to please start with your presentation. Hello. Anyone from the paper title Optimization of Routes of SDN using GNN and DRL, are any of the co-authors present for this paper? Okay, we will move on to the next
Is
paper
there,
title.
yeah, please. Is any author available in the meeting?
I don't think anyone is available from this paper. Just Abdul Razak is available. Sir, are you able to hear us?
Hello,
Hello?
Wha-
Hello?
ma'am. Just a second.
Okay, sure, sir. Please start with your presentation. Is there any issue with the presentation?
No, no, ma'am. Not a issue. I'll give it. I will.
Okay, so can you please start with your presentation now?
Yeah, yes, ma'am.
Okay.
Uh, screen share. Screen share. Ma'am, is my screen available?
Yes, sir, we can see your screen. You can start with your presentation.
So, good morning. I'm from KLE Technological University, and the paper ID is 85. Our title is Optimizing the Roots of Software-Defined Networking using Graph Neural Networks with Deep Recurrent Learning. So these are the contents of the file. Coming to the project initiations and the objectives and scopes. This phase involves like setting up the project goals, objectives, and scope. Our main objective was improving the routing efficiencies in software-defined networkings and the graph neural networks. This is the literature review we have conducted. We have reviewed around 30 to 40 papers in the software-defined networking, and around the main objectives with which were the routing optimizations. The main algorithm which they have used are GNN. We have optimized it with regards to deep recurrent learning also. These are the data set which we have collected. The first one is NEPSET topology dataset and the GAN2 topology dataset. NEPSET is basically it has graphs and nodes and adjacents, which was one of the major backbone of the internet in early 1990s. The primary use is for training the reinforcement learning agents with a focusing on routing optimizations and aiming to minimize the overall network delays. Our main focus is on three things: uh, throughput, Hello.
Yes, your voice is not audible.
Yeah. Hel- Am I? Hello. Am I audible now, sir?
Yes,
Yes,
now.
sir, you are audible.
Yeah. Our main goal was to optimize three things: nodes, edges, throughput, and latency, which is also mean as latency and packet loss. Coming to the second data set is GAN2. We have integrated two data sets. We have not only used one, but we have combined the two data sets, that is NEFSET and GAN2 topologies. The data sets were large, and it was nearly impossible to train our model. So we have used the GPU systems which are provided by the college. We have used RTX 39. So these are the NEFSET topology dataset, which have around 14 nodes, and this is the GAN2 topology dataset, which have around 24 nodes and 32 edges. This is nothing but the aspects of the dataset which we have used. The two different datasets which we have used. You can see like 14 nodes and 21 edges, and larger with 34 nodes and 54 edges. Most of the SDN papers which the other co-authors have published, they have also used the same GNN algorithm, but we have combined it to using two datasets, and we have also used the deep recurrent learning model. So this is the functional block diagram. You can see that basically our GNN based model focuses on three things: delay, jitter, and packet loss. After that, the optimizing routing engine will be performed, and the link weights will be automatically updated. And again the routing optimization happens, and then the output performance improvement the performance will be automatically improved. These are the key points of the algorithms, which are map queues, map path, and reduce to reduce the overall packet delay, jitter, and packet loss. We have also computed the QoS parameter, which is meter related to jitter and delay. Our first iteration initially assumes no packet loss for the calculations. We have assumed it for function zero iterations. As we always know, the iterations start from zero, and then it goes out to the till the edges and the nodes are till the extent. So in the initial phase, we have assumed that there is no packet loss. After that, we have initially increased our training models and efficiency of the model. So yeah, we can see that this is the output execution time. It is eventually increasing, like time in milliseconds. It is eventually increasing with respect to the topology sizes and the number of nodes. This is the QT model, it is a traditional technique which is being used, and this is our model, DRL plus GNN model in the green color. We can see that the initial 10 to 30 nodes, like we can see that in the traditional algorithm, the in time in milliseconds is around 0 to
Hello.
26 seconds.
Sir,
Hello.
sorry for the interruption, but we are past the presentation time. Can we please get to the conclusion?
Yes, ma'am. Yes, ma'am. Like this is the mixed GNN and output model for that. So the calculations which we have assumed, and the relative error which we have calculated. So these are all the outputs. Like we can see that delay, jitter plus GRL plus GNN and QT model which we can see. These are the references. Thank you. So coming to the conclusion part, we have optimized the routing efficiencies and the nodes and edges of the graphs. Thank you. In software-defined networking.
So
Thank you,
when,
ma'am.
what was the idea behind taking the two data sets like NSFNet and
GAN2, yeah, yes, sir.
GAN to
The
both
idea,
together?
Yes, sir. Like the idea was in traditional algorithms, which we noticed, sir. They have took one data set, but the data set was lagging in one data set has jitter and delay qualities, and the other one we have taken it for QoS parameters.
Okay. So in these two gadgets, which data set is having more edges and more nodes?
Yeah, sir. GAN2 is having more edges and more nodes, sir.
Did you find some
We
specific
can.
comment for that? That because of these more edges and more nodes, we are able to find in the result.
Yes, sir. It was initially hard for us to train our model. Uh, like, I beg your pardon, sir. Like, can you come once again?
Yes, it would be the difficult to train a model, right?
Yes, sir.
So, did you find any point in which which states that the more nodes and more edges can give then better result?
Yes, sir. We initially had taken a different data set initially. Again, we came to NEFSET and GAN2, we combined it together. So what we noticed is a reduced time in latency and delay, sir.
Okay, good. Thank you, Rajat. All the best.
Yeah. Thank you, sir. Thank
Thank
you.
you, sir. Now I'll move on to the next paper. The next paper title is again from the same presenter, which is Mohammad Azruddin. And the paper title is Performance Analysis of Wireless Routing Protocols. So, any of the co-authors who will be presenting on his behalf, please respond.
Yes, ma'am.
Okay. Sir, please start with your presentation. After 7 minutes, I will raise a gentle reminder. You can share your screen now.
Ma'am, is my screen visible?
No, sir, you haven't yet shared your screen. Is there any issue?
Yeah, ma'am, just a minute, ma'am.
Okay.
Ma'am, now my screen is visible to you?
Yes, sir, we can see your screen.
Yes, ma'am. Thank you so much. So, good afternoon to all respected faculty members, reviewers, and the attendees. We thank the organizers of ICT Goa 2025 for giving us an opportunity to present our research project today. We are a team of 4 students. So, we are from Keli Technological University, and our main focus is on evaluating different wireless routing protocols in MANET using simulation in NS3 simulator. So, I'm Ilyas Kinal. I'll be presenting our research-based project that the title says Performance Analysis of Wireless Routing Protocols. So, in this project, we evaluated the performance of all the 4 major MANET routing protocols that are AODV, OLSR, DSDV, and DSR using the NS3 network simulator. Our aim was to understand how these protocols perform when transmission power is varied. So, we simulated each protocol under 2 different levels here. So, one was like 7.5 dBm and another was like 9.5 dBm. So the key performance metrics analyzed were throughput, packet delivery ratio, and packet loss. The final goal was to identify which protocol performs most efficiently under the real world conditions. So a problem statement says, so in managed, that is like mobile ad hoc networks, these are basically wireless networks where devices communicate without any fixed infrastructure. So due to node mobility and changing various signal strength, maintaining the stable communication is a very big challenge. So different routing protocols respond differently to these variations. So we wanted to see how like changing the transmission power would actually affect the performance. So using NS3, we try to compare the all the 4 protocols under the controlled conditions. Like so the manets are widely used in the areas where setting up the traditional network is difficult, such as like military missions, disaster recovery, and remote communication. Routing in these network is challenging because devices keep moving and signal strength
I'm
constantly
sorry
changes.
to interrupt, but I
Sir,
think your presentation is not visible. Only the screen which shows your home and file is visible.
So you did not open your PPT actually.
Ma'am, was it not visible?
No, actually you shared your screen, but we couldn't see your PPT. We were just seeing your file section.
Now, ma'am?
Just
Wait,
give me a second. Yes, now we can see
yes.
it.
So I'm
Please continue.
really sorry, sir. Like I was just trying to like share the screen, but eventually I couldn't cope up with
No
it.
issue.
Sorry. Yes.
No issue.
So
You
I will.
just continue. You just continue with the slide where you were.
Yes. So routing in these networks, like it is very challenging because devices keep on moving and the signal strength constantly changes. So to handle this, we use routing protocols like AODV, OLSR, DSDV, and DSR. In our project, we tested these protocols under two different power levels and analyzed how the performance was trying to vary in the in the NS3 network simulator. So the like core motivation behind that was like in import like first of all if I say that manets are very important in the real world applications, but maintaining the reliable communication is very difficult due to the dynamic conditions. Every protocol behaves differently when power, like mobility and topology changes. So we were motivated to identify which routing protocol adapts best to the each conditions. So also understanding the effect of transmission power levels, like how to improve in the real world deployments. So this comparison is valuable for research and engineers working on manets. So the objectives for our project are like to simulate the all the four protocols using NS3 to test the performance at 7.5 dBm, that is lower power level, and upper power level as 9.5 dBm where we have considered here, and the other parameters are kept as constant. So uh, to measure the throughput, packet delivery ratio and the packet loss are the like key metrics that we have used here. And finally, to find which protocol is like challenging into which power conditions. So in the literature survey part, we had reviewed like some existing papers based on manet. We had also like studied upon the NS2 and NS3 simulators also. Mostly were focused on single power levels, but our study adds a value by comparing the same setup under two different power levels. Like it will be much more understanding protocol behavior for realistic signal conditions. So in this protocol overview, as you can see here, that AODV is more reactive, like it finds the routes when needed for good mobility. OLSR is like proactive, it updates continuously or regularly. And DSDV, it is like table driven or low delay but constant updates. DSR is reactive, uses source routing and caching. So in the methodology, in the methodological part, uh, we first configured the simulation parameters in NS3 and we ran simulations for each of the protocol. For 7.5 and 9.5, we logged the output to CSV files, including throughput and packet count. After the simulation, we compared the performance using the CSV files. We also used GNB plot scripts to visualize the throughput and PDR for each protocol. So here in experimental setup, we used NS3, that is like our discrete event simulator, and the setup basically involved here is like 50 mobile nodes that we have considered in an area of 300 into 1500 meters. So mobility was applied in the random waypoint model. So traffic was generated via UDP, that is on off applications. The two transmission power levels are mentioned above, and the time duration that simulation that has been taken is 200 seconds. So the uh, performance metrics that we are trying to actually measure in our output was throughput, PDR, packet loss, and delay. So this was our block diagram that I had created. So basically, after the setup of the simulation, there will be a node creation from which there we have considered like four protocols. So after the packet transmission, we are actually measuring which of the protocols is like suitable for the real time conditions. So here let me go quickly to the results part at 7.5 dBm and 9.5 dBm. So at 7.5 dBm, what actually happened was the signal strength was slower. AODV showed moderate, but the PDR was also unstable throughput. OLSR gave us the high PDR and stable performance. DSDV remained consistent, but not the best. DSR was irregular due to route caching problems. Lower powered reduced coverage area causing more packet loss. But in the 9.5, we got like stronger signal that improved the actual performance. AODV was much better in both the PDR as well as the throughput. OLSR stayed stronger and more stable. DSDV slightly improved, but DSR remained inconsistent. Higher power helped deliver more packets and reducing the loss. So, the proper conclusion, for the project, what we can say is from our results, OLSR was the most consistent and effective protocol overall. AODV showed improvement at a higher power, making it suitable for dynamic networks. DSDV was average but stable. DSR did not perform well under the different mobility. So, protocol choice should depend upon the power and mobility of the network. So, the future plans that we are looking forward is to plan to include the delay and jitter part also and add some energy models to it. So we also want to test to more hybrid routing protocols like ZRP and evaluate performance for large densities and larger area. So this was our project, sir.
Thank you, sir, for your presentation. Is there any question?
It was the nice work, Julius, and nice comparative analysis of this performance analysis. This time I don't have any real question there. Thank you. Just of
Okay.
Yes, sir. Thank
Now
you so much.
we go on to the next presenter. So the next presentation is by Soni R. Raghu from Vidya Prasirini Sabhas College of Engineering and Technology. And the paper title is Plant Leaf Disease Detection System using Deep Learning. If any of the co-authors or the author is present in the meeting, please give me a response. Okay, I think this person is not there, so we will move on to the next presenter. The paper title is Pneumosense Smart Pneumonia Detection Using Deep Learning, and this paper will be presented by Prerna Agarwal. Ma'am, please start with your presentation.
Yes, ma'am. Am I audible?
Yes, ma'am, you are audible.
Yeah, just a sec. Is the PPT visible, ma'am?
Yes, ma'am.
Okay. Yeah. Good afternoon, all of you. Myself, Dr. Prerna Agrawal, with my co-author, Dr. Savita Gandhi from GLS University. I am here to present the research paper on the title named Pneumosense, a smart pneumonia detection using deep learning. This is the roadmap for our presentation today. We have introduction, then we will discuss the workflow model of Pneumosense application. Then we have the data set used, we have experimental methodology, then we have its results, findings and discussion part. Then we have a comparison of Pneumosense with other models. And lastly, we have conclusion and its future work. As we all know, pneumonia basically is the leading cause of illness and death, especially in children. and mostly in elderly people. So early and accurate diagnosis of pneumonia is very much important, using of machine learning and AI techniques. So traditional pneumonia detection currently in manual processing is going on through chest x-ray, but again it's time consuming, and again the results of manual interpretation are depending on the expert radiologists. So in India, basically we face many regions which are not up to the mark, which are low resources, or which are, you can say, middle regions, which have shortage of radiologists, so that causes delays in the diagnosis. So we have some statistics of pneumonia of 2022-23. In that we have top three states, that is Uttar Pradesh, Rajasthan and Madhya Pradesh, that has maximum number of deaths due to pneumonia. And in infants we have 11,497, and from babies of 1 to 5 years we have 4,557, 4571 children who are suffering from pneumonia and having deaths. So here there was a need of a system which is fast, reliable, user friendly for pneumonia, early pneumonia screening and diagnosis. So pneumosense basically is a deep learning based system to detect the pneumonia from chest x-rays, and which is built upon DensNet 122 deep learning model. Now this is basically the workflow model of the pneumosense application, or you can say the model. Firstly, the user has to upload an x-ray image. If the x-ray image is uploaded successfully, then a pneumonia detection will be performed using deep learning model, that is DensNet 121. If the pneumonia is detected from the chest x-ray, then a message would be displayed that you are likely to have pneumonia, please consult a doctor, and again the prediction score will be displayed. And if the pneumonia is not detected, then a message will be displayed, you are not likely to have pneumonia. So this is the workflow model of the pneumosense. Now, this is the data sets that we have used for the pneumonia. So we have basically tried to accumulate as many data sets as we can for pneumonia, so that we can get a different variety of data sets from different sources. So there are total 14,531 pneumonia images, and 14,288 normal images were taken, and the model deep learning models were trained and validated on 14,141 images and 13,986 normal images. So the dataset basically was partitioned into two groups, training and validation, with a ratio of 80:20. And the testing set was altogether different. So the testing set consisted of 390 pneumonia images and 302 normal images. So this was the thing for the data set that we have used. Now the experimentation methodology comes across that we have accumulated variety of data sets for pneumonia detection. So all the experiments basically were carried out on the laptop only, whose configuration was Intel 12 core i5 processor with 8 GB RAM. And the tools and technologies used were Anaconda Suite, tkinter, TensorFlow and Keras libraries for deep learning classifiers. And again, Python was used for development of pneumosense. So deep learning algorithms used for the experimentations were CNN, ResNet 50, NASNet and DenseNet 121. Again, for augmentation process, we have used, or we have converted each and every X-ray images into 150 by 150 pixels, and then it was used for the further analysis, for training also and for testing also. Now, the evaluation criteria that we had for our experimentation methodology was accuracy, precision, recall, F1 score, AUC, training time, and inference time. So basically, these are our results. So we have used four algorithms, and these are the results based on accuracy, precision, recall, AUC, F1 score. So here it is clearly visible that DenseNet 121 algorithm outshines and performs exceptionally with the AUC value of 98.08% and having a recall of 97.95%. And when we talk about the training time and inference time, again, CNN is taking less training time and inference time. So when CNN is most basically suitable for time sensitive applications, but you can say DenseNet 121 all over delivers the best performance for with its high latency, and it's practically reliable for real-time deployment. Again, we have the confusion matrix values, in which you can see that in DenseNet 121 you have true negative and true positive values maximum from all the algorithms. That's why for NumoSense, after so much experimentations, for NumoSense, we came into conclusion that we will be using DenseNet 121 for our prediction of pneumonia, early prediction of pneumonia. These are the confusion matrix of all the four algorithms you can see, and these are the ROC curves of all the four deep learning algorithms performed by the experiments to create the NumoSense model. Now, again, these are different X-ray images used for experimentation in our model basically. So we have created NumoSense model, and NumoSense model was again tested by different images, pneumonia images as well as different diseases images also, and with the normal images also, to prove its reliability and accuracy. So here are the GUI screens and the detection results of the NumoSense. The first screen is, for example, any image, X-ray image will be uploaded. So for example, the first screen says it's we are uploading an image of edema, but again here it will only check that that specific chest X-ray image is having pneumonia or not. Fine. So another disease image is uploaded. So here you can see in the detection of edema, it is clearly telling not likely to have pneumonia. So this basically, this is the testing case of hernia, again fibrosis. So again it gives the message that you are not likely to have pneumonia. And here in the
Ma'am,
last use case, yeah.
ma'am, sorry for the interruption, but we are past the presentation time.
Okay, just 2 minutes. So here the
Yes.
detection of pneumonia is done with the prediction score, and here the detection of normal image is there. Fine. So again, here it's the comparison of our NumoSense model with other models, with recall and AUC. So we have compared three models with that. So it again clearly shines out that our NumoSense model has highest recall and highest AUC compared with all other real-time models. Now, the last part is the conclusion. So basically, obviously, NumoSense is a deep learning model which is used for early detection of pneumonia in chest X-ray images, and it is made up with DenseNet 121 model, which performs very well with high recall rate, that is 97.95%, and AUC is 98.08%. So NemoSense again, it's a user friendly, which allows simply any user to upload X-ray image, and in return it will detect the results that the person is having pneumonia or not. And again, our application or model is evaluated against different lung diseases like hernia, fibrosis, effusion, cardiology, etc. Now the future scope is it can focus on expanding the data set also of NumoSense for real world clinical settings. Again, second, another hybrid techniques, hybrid deep learning techniques, and again hybrid models and more techniques of hybrid deep learning can be accumulated or tested with this to improve the results of pneumonia. Again, we are working on this, and we have developed one more model, that is NumoSense plus plus, in which again we have gone for more testing in deep learning, and we have enhanced the results of NumoSense. So we are already working on this, and we have already created an enhanced version of this. So obviously this study will recommend when NumoSense be integrated into, it can be integrated into areas, low resources areas, into hospital systems, and it can be a very advantageous resource for you can say low resource places. So this was all about our presentation, and these are some references. Thank you. Any questions?
Yeah, just one thing. Have you collaborated with any medical doctor regarding this, especially when we want to distinguish between the fibrosis, hernia, and pneumonia?
Yes, sir. We have collected some of the images, normal images and pneumonia images from radiology centers as well. So we have already collaborated, and some data set we have collected from Kegel, and some data set is collected from real radiology centers as well as hospitals.
That's good. But after collecting the data set, did you share your
Yeah.
result with any medical professional like Dr. MBBS, doctor, and
Right now, this application, sir, is under construction. And as
okay,
I told you that we are already working on the enhanced model, that is pneumosense plus plus, and we have already written one more paper on pneumosense plus plus also. So right now we are working on the pneumosense and pneumosense plus plus. So as we get enhanced results, more enhanced results, we are going to share in the real time, and we are going to deploy the system in the real time, which will help the
okay.
hospitals. So we'll be doing it for it Indian population.
So Nimitz, okay, great. All the best.
Yeah, thank you, sir.
Thank you, ma'am, for your presentation. Now, we move to the next presenter. So the next presentation is by Vani KS from Nitya Meenakshi Institute of Technology, and the paper title is Real-Time Sentiment Analysis of Help Desk Calls Using LSTM and NLP for Emotion-Aware Customer Support.
Hello.
Ma'am, yes.
Yeah, is my screen visible?
No, ma'am.
A second, please.
Ma'am, it is visible now. You can start with your presentation.
Okay, thank you. Good afternoon, Dr. Paris and everyone present. We are here to present a
Good
final
afternoon.
project titled Sentiment Analysis of Incoming Calls on Help Desks. Under the Department of Information Science and Engineering, this project was guided by Mrs. Vani KS and done by me and my teammates. We are grateful to have your time and attention for this evaluation. Today, customer satisfaction is a top priority in every company. While most sentiment analysis systems focus only on text data like emails or chats, voice calls are often ignored. Our project focuses on understanding emotions in voice during live help text call. We used deep learning techniques called LSTM that can understand patterns in audio like tone, pitch, and expression. The goal is to help agents respond better in real time based on how the customer is feeling. The literature overview. So we went through multiple.
Hello. Ma'am, your voice got interrupted. Is there any issue? Hello.
Hello. Yes. Uh, sorry. Is there an intervention from my side?
No, sir. I think she just stopped talking. There might be some network error from her side.
Okay.
We'll just wait for a minute. Meanwhile, other participants, please be ready with your setup. I think she has left the meeting. There might be some network error. We can have our presentation later on. Meanwhile, we should just proceed further.
Yes.
So the next presenter is again Muhammad Azruddin, and the paper title this time is V2X Communication for Enhanced Vehicular Safety. Uh, any of the co-authors who are going to present this paper, please respond. Think the co-authors are present for this one. It's all right, we will move forward. The next paper title is Water Quality Prediction using AWS and Machine Learning. And this paper title will be presented by Pininti Anju Chaudhary from Amrita Vishwa Vidyapithan. Ma'am, you're there in the meeting. Please give me a response.
Yes,
Ma'am,
ma'am.
you can
Give
share
me
your
a-
screen and start with the presentation.
Yes, ma'am. Is it visible?
Yes, ma'am.
Good evening, everyone. I am Anju here with my teammates. We are students from Amrita School of Computing, Bengaluru. Today, we'll be presenting our project titled Water Quality Prediction using AWS and Machine Learning. In this project, we built a full stack cloud deployed system that predicts whether water is safe or unsafe using machine learning models trained on real world data sets hosted using AWS services like Elastic Beanstalk. Water quality monitoring is essential, but traditional methods are slow, manual, and often expensive. For example, collecting samples, sending them to a lab, or waiting for results is not only time consuming, but also doesn't support real time decision making. We wanted to build a real time, scalable, and accessible system using machine learning and the cloud. The aim was simple: allow users to input a few water parameters like pH, turbidity, chlorine, and instantly get a prediction or water safety accessible from anywhere. Uh, Here, an overview of system that we have built: a machine learning model that classifies water as safe or unsafe based on quality parameters, a Flask web application that acts as the user interface, and deployed it on AWS cloud, primarily using Elastic Beanstalk with tests on Lambda and EC2. This allowed us to create an end-to-end pipeline from data input to model inference to prediction output, all hosted online.
Ma'am,
So
are you not changing your screen?
yeah,
Okay, it's
I
better.
think.
Yes, okay, okay.
So we collected our data set from Water Resource Information System. It contained multiple parameters like pH, turbidity, total dissolved solids, dissolved oxygen, hardness, and more. Steps taken was data cleaning. We removed null and outlier values. Feature engineering means selected only impactful parameters and ensured uniform scales. Finally, we split the dataset into training, validation, and test sets in 70, 70s to 15 into 15 ratio. Uh, We trained 6 different machine learning models using Python and sklearn library. The models we have trained is logistic regression, decision tree, random forest, Naive Bayes, uh, KNN, and support vector machine. We evaluated each model using accuracy, precision, recall, and F1 score, where SVM gave the best performance accuracy from the SVM is 92.7% and the F1 score is 92.3%. So we finalized SVM and saved it in a .pkl file format for deployment. So when we are coming to Flask application, to make the system interactive, we created a Flask-based web app. It has a simple HTML front end where users enter water quality values, a Python backend that loads the SVM model and returns predictions in real time. We validated the input fields, implemented error handling, and tested it locally before deploying it to the cloud. This app is the core user interface, connects directly to our prediction model. So coming to AWS deployment options, we have explored three development methods. The first one is AWS Lambda, serverless and cost effective, but we could not load our large .pkl model due to size limits. It gave errors like not found because sklearn was not compatible for Lambda because of its size issues. So it was not our option. Then we moved to AWS EC2. That is a full control over instances but required manual configuration. We faced instant crashes when memory was not allocated properly and all. So finally, we took so finally, we have taken AWS Elastic Beanstalk. This was the best choice. It handled all our dependencies automatically, allowed scaling, and provided public URL for access. So this is our dashboard. This tells this is like user sets parameters via Flask UI. This is the UI. The app sends these backend hosted on AWS Elastic Beanstalk, and the SVM model is loaded and a prediction is returned. The results safe, unsafe is displayed instantly. Behind the scenes, Beanstalk provisions EC2. Manages scaling. S3 was used temporarily for file storage, and CloudWatch helped us to monitor the logs, errors, and all. So, see here you can see that our model was it is gave us a save where we have our model SVM model was compared against the standard WHO guidelines where example pH of 7 falls with the safe range 6.5 to 8.5. Turbidity at 0.5 NTU is well below in the unsafe threshold. Like this confirms that our model is reliable, provides accurate classifications in real world use cases. So the challenges we have faced were the first one is, as I have told, we have used Lambda. It could not handle model size and dependency management. And then we moved to EC2, crashed due to improper instant sizing. Initially, lack of containerization caused inconsistencies between local and cloud environments. Building dependencies for Flask with ML libraries took multiple iterations. These experiences taught us to choose cloud services based on model complexity and runtime constraints. So, in conclusion, we to summarize everything, we built a machine learning based water quality prediction system integrated into a Flask web app, deployed using AWS Beanstalk, achieved a 92.7% accuracy using an SVM model, tackled real world deployment challenge, and learned a lot about cloud architecture. Thank you, sir. we'd be happy to answer any questions.
Yes, thank you, Anju. It was nice. Is this your project?
Yes, sir.
Are you studying in MTech?
No, sir, BTech.
BTech project, very good. Very good initiative you have taken. So tell me, Anju, how will you take this further as research as well as a business model, right? To predict the water quality with the various models which you used in this project.
Sir, right now it is only Flask web app, which is basically a local server kind. We need to make it on a large scale. Like, even though we have used it on a cloud based, it is only a what do we call 1 month subscription type of cloud we got. We need to make it in a large scale. The web app, we need to make it in a large scale.
Okay. All the best for your career, Anju. Thank you.
Thank you,
Thank
ma'am,
you,
for your
sir.
presentation. Now from one of the Vanji case co-author is she has restored her connection. She would like to continue with her presentation. Kaityani ma'am, you can start.
Okay.
Just start from where you had left last time.
Sure. I'm so sorry, by the way. So, am I presenting my screen again?
Okay.
Is it visible?
Yes.
Okay. So, I was addressing the research gap. So, we've identified 4 major gaps. First one was real-time performance. Many models are slow or laggy. Another was handling noisy audio. Most systems expect clear inputs. Then high computation cost, not ideal for large-scale use. Deployment issues, difficult to plug into real call center. Our aim was to build a system that can overcome these issues. Now, the main motivation behind this was we were motivated to create a system that could give real time feedback to support agents, help improve customer satisfaction immediately, be robust even in noisy call environments, and also be efficient and scalable. Then the main problem statement was to develop an accurate and real-time sentiment analysis system for help desk voice calls that helps in understanding customer emotion and improving service quality. The objectives were build a speech emotion recognition model using deep learning, extract useful features from voice using MFCC, train the model using LSTM network, ensure good accuracy across various emotions, and visualize the result to analyze performance. The methodology that we had and the approach we used for the project was we collect emotional voice data from Kaggle, pre-process the audio using MFCC, which captures tones and patterns, built an LSTM-based model that can understand sequential audio, and trained it using proper parameters, batch, size, epoch, optimizer, etc. This is the system design of a project, which first consisted of data collection, where we imported label speech audio files, then data preprocessing, which included of load audio, applying MFCC feature extraction, then data splitting, splitting the training and validation sets, model development with the help of LSTM, model training using cross entropy loss and Adam optimizer, and then finally evaluation testing, which would validate the accuracy and the processes. This was the MFCC example. Next up, we have the LSTM summary, which included of layers, which are dense dropout, dense 1, dropout 1, and dense 2. Then finally, the accuracy curve and loss curve that we had, the confusion matrix, and the references. We refer to multiple IEEE papers and research articles to understand and build our system better, focusing on models that use deep learning and speech signals. Thank you so much for your time and attention, Dr. Kothari. We also thank our guide, Mr. Vani Case, for our continuous support and guidance. And we are open to any feedback you may have.
Ms. Jaiswal, very nice. In fact, is the first of this category paper of the sentiment analysis in this session. I would like to ask one question. Why have you selected this LSTM and NLP model for this sentiment analysis?
So, sir, basically we use this LSTM model because it is very good at handling sequential data like audio. In voice speech sentiment analysis, it's not just about the words. The way something is being said also matters. LSTM can remember long-term dependency like changes in tone, pitch, and pauses, which help in understanding emotions more accurately. And since we are dealing with spoken conversations, combining NLP techniques like MFCC feature extraction with LSTM helps us capture both the acoustic and semantic patterns in speech. Therefore, sir, we use this for better results.
Basically, it is the recurrent neural network model, no?
Yes, sir.
RNN kind of model.
Yes, sir.
So my question was like that, ki why RNN?
Why RNN? Sir, we know that.
Not to worry. If you can answer, you can answer it. Because it was my query, so I think I should ask it to you. If we another models for sentiment analysis, then why should we go with the RNN? What are the what are the benefits over other models using this LSTM? It's a short-term something model, large and short-term memory model.
Yes, sir. So, like for CNN, these are good for images or fixed size inputs. But since we are handling speech, timing and sequence matter a lot. So that is why, sir, RNN was a better fit.
Because your speech and sequence is also not.
Yeah, yeah, sir.
Okay. All the best, Katyani.
Thank you so much, sir. Thank you for having us.
Thank you, ma'am, for your presentation. Now, at last, I would like to call out a few names, of which the papers are yet to be presented. Soni R. Raghu. Is anyone from her team or any of the co-authors present in the meeting who would like to present the paper? If not, then we can proceed with the closing remarks. And one paper from Muhammad Azruddin is also left and it has not been presented. Anyone from that project? Okay, so now I'll just proceed with the closing remarks. Then we are done, pretty much done here with all the presentations. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during the 10th version and all the previous 9 versions of this conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD. And lastly, before ending this session, I would like to thank our session chair, Dr. Paras Kothari, for chairing this session and for your valuable presence and insights.
Thank you, Siddhi.
A token of appreciation to the chair on behalf of Team ICT4SD and Global Knowledge Research Foundation and partners. Now, just before ending this session, I request all the participants to please turn on your camera so that I can take a quick snapshot of today's conference. We'll just wait for 10 seconds for everyone to. Okay. Okay, done. I've taken the snapshot. Now everybody is free to leave. Thank you, everyone.